Now we are going to start with the chemical properties of 16 group. But before we do that, as you know that you are familiar of the series of the group which we have in the 16. So I just want to tell you that that first element is as you all know that in the whole periodic table, in each and every group, the first member differs from the rest because it has certain special properties. So here our first member is oxygen. So let's see that what special properties it possesses. So the first property is that it has the small size. We know that size increase down the group. So if we talk about the members of the family, oxygen is going to possess the smallest size. Being smallest, that indicates that it is highly electronegative. That means tendency to attract shared pair is more because it is small, so nuclear charge is very high. So it has a tendency to attract shared pair of electron more towards itself. Let's see the structure. See, if you will see the structure of the water, it will be somehow like this. Right, and if you see the structure of H2S, it will be like this. So as you have seen that because it is electronegative, so it requires a partial negative and it requires a partial positive charge. So that means this molecule is polar, and this polarity indicates that it is an electronegative in nature. And the third property is that it has no vacant d orbital. So it has no vacant d orbital, that means it cannot extend its oxidation number up to beyond a certain limit. So maximum covalency which it can exhibit is +4, but generally it exhibit +2. Generally it exhibit +2, and moreover it is a gas. And as though you can see that it is polar, so it is being small in size also, and polar also indicate that it is capable of forming in hydrogen bonding. So that means it can get into hydrogen bonding, right. So now we are going to start with the chemical properties. So three important chemical properties we have observed for the 16 group. First is the reaction with hydrogen, second is the reaction with oxygen, and third is the reaction with halogen. So first we are starting with the hydrogen. So what happened, we know that anything when react with hydrogen, it forms the respective hydride. It forms the respective hydride. So the element of this group, maybe oxygen, maybe sulfur, or any member of the family, they react with hydrogen forming a element hydride. And the formula for the element hydride is basically EH2. As we will see, when hydrogen combines with oxygen, it forms H2O. When it combines with sulfur, it forms H2S. When it combines with selenium, it forms H2SC. And when it combines with tellurium, it is H2Te. And now we will look for, that means all of the members are just, they have the affinity in reacting with hydrogen, that is why they are forming their respective hydrides. So let's look for the properties in them. So the first property is bond angle. So what is the bond angle? We know that it is actually due to the repulsions present between the bond pairs, bond pair, lone pair, bond pair, or lone pair, lone pair. So then due to this there exists a certain angle between the lines that joining the bonding electrons. So here the angle between H2O is 104, in H2S it is 92, in selenium it is 91, and in tellurium it is 90. So we see that bond angle decrease down the group. Bond angle is decreasing down the group. That means there are you can say because when we move down, so that means they are coming more closer. So that means there are repulsions are increasing as we are moving down the group. The second property is melting and boiling point. We see that if we if we arrange them according to the melting and boiling point, it is going to possess the high melting point as compared to H2S. Otherwise, we know that as we move down, the size is increasing, molecular mass is increasing, van der Waals force is increasing, therefore the melting and boiling point is increasing. But if we compare between H2O and H2S, what we have observed that it is more for H2O. The reason being, it is capable of doing hydrogen bonding, but this kind of bonding cannot be done by H2S. So that is the reason, right. So this is what is the melting and boiling point. Otherwise, when we move down the group, melting and boiling point increase, because we know that when there is an increase in atomic number, molecular mass increase, the surface area increase, and therefore the van der Waals force increase. So due to which the melting and boiling point increase down the group. Next is the acidic nature. Acidic nature indicates that how fast or how easy they can liberate their hydrogen. So we see that as we move down, so first I will write the order for the acidic nature. So in this H2O is least acidic, sulfur is more acidic than this, Selenium hydride is more, tellurium is more. So likewise, when we are moving down, the acidic character increase down the group. Now what is the reason? We know that small cation can stabilize the small anion, or a bigger anion can stabilize the bigger cation. So that means when we are moving down, we know the hydrogen size remains the same, but the size for this is changing continuously. So that means there doesn't exist a strong force of attraction. And when there is no strong force of attraction, that means the bond is not so strong, and therefore it leads to less bond dissociation energy, and the release of hydrogen is much easier. So that means acidic character decrease down the group. Next we have thermal stability. That means when you heat it, so in which out of them need less heat to get separated. So obviously this one will require less heat because it is not stable. So or you can say that here the force of attraction is not too high, so that means there is no strong bond, so less heat can just separate them. So if we talk about thermal stability, water is maximum stable, and thermal stability again decrease down the group. Next is the reducing character. Reducing character is tendency to lose hydrogen, right? Tendency to reduce other, and how it reduce? By giving its hydrogen. And how it will give hydrogen? If less strong is the bond, more easy it can give. So we have seen that acidic character increase down the group. That means the tendency to release H is somehow increasing down the group because there is decrease in the bond dissociation energy. So release of H is easy. So that means reducing character increase down the group. Next we have is stability. Stability and thermal stability is somehow stable because almost similar, because thermal stability indicates that what amount of heat you need to supply in order to break, and stability means that you are not breaking anything, but you are just looking that where the strong bond is present. So we see that the strong bond is present in the first one, but as we move down there the bond magnitude is going on decreasing because the size difference, as I told you, that a small cation can stabilize the small anion and the bigger cation can stabilize the bigger anion, right? So this is the reason. So that means this one is the least stable and it is more stable. So again it decreased down the group. So this is what is the reaction with hydrogen. So now we are going to start with the second property, that is the reaction with oxygen.